Alright, final review number 4. Similar to the Ferris wheel, so we're trying to swing a 4-kilogram object in a vertical circle attached to a rope. So step 1 is to find the centripetal force, which has the equation of mv squared divided by r. Mass is 4, velocity in the problem is also 4, and the radius is 0.5. So you plug in all the information that you have, which is 4 times 4 squared divided by 0.5. You end up with a force of 128 newtons. If this object was just sitting by itself, it would have a force of gravity of 40 newtons, so it feels a little heavier. Now part B, what's the tension in the rope at the top? So again, just like the Ferris wheel problem, at the top you are going to end up with a force pulling downward. And with that force pulling downward, and that force pulling downward is the force of gravity. So then you end up with other relationships with the other forces. There's tension, and there's a centripetal force. Tension is pointing down because it feels like it is tightening downward, and then centripetal is pointing up because that's the result of the centripetal force. You end up with a relationship that says tension is equal to gravity minus centripetal force. It's very similar to the problem like before. Now, what's going to happen if you look at what you know? Force of gravity in this problem is small, centripetal force is larger. When you do this calculation, you're going to end up with a negative number. So it doesn't matter if centripetal or gravity goes first in this situation. So you're going to end up getting the same numerical value. So don't worry about the sign for this part. So force of tension is equal to mass times gravity minus 128. So that's going to be 40 minus 128. And that's going to result in a value that is going to be 88 newtons. Alright, part C. Tension at the bottom. Again, relationship's the same. If at the top the two values are subtractive, at the bottom that means that they're going to be additive. So you end up with force of gravity plus force of tension to get your value. Now, that top free body diagram is a little funky because based on the equation it should be tension plus centripetal equals gravity, so I drew that wrong, so ignore that, sorry. Alright, and then the same thing with this one, gravity and centripetal are additive at this case. Alright, so force tension is equal to Fg plus Fc. You end up with 40 plus 128 to get a total of 168. So that's the force of tension at the bottom compared to the force of tension at the top. Now the next part is totally separate from this information. You don't need the forces to calculate this. It says how long will it take the object to complete 10 revolutions. So when you know what happens with a revolution is that it travels the circumference divided by the period. So when you end up getting to that point, you're going to use the formula for circumference, which is 2 pi r, and then use the period to figure out how many seconds it takes to go around 10 times. So the formula again, velocity equals 2 pi r divided by period. We want to know how long it takes for 10 full revolutions, so that means we want to go around the circumference 10 different times. So formula-wise, the first thing that you have to do is find the time for 1 using the velocity that was given in the problem of 4 meters per second, the fact that you know the radius and you know this equation. So you plug in what you know, which is the velocity is 4, and then the radius is 50 centimeters, and you're looking for period. So that's going to be 2 pi times 0.5 divided by t, and that's equal to 4. So you end up getting a formula, or a value, I'm sorry, for a period of 0.79 seconds. So that's the time that it takes to go around 1 time. The problem is asking for how much time it takes to go around 10 times. So you take the time it would take for 1 and multiply it by the times that you're looking for. So since we're looking for 10 times, we're going to take the period multiplied by 10. So 0.79 times 10 ends up being 7.9 seconds. There's another option, and that's to find the total distance that's traveled in 10 revolutions. So you could find the circumference, multiply that by 10, and then divide by a time, and that would give you the total time as well. You still get 7.9, it just depends.